In this video, we're going to be talking about hyperbolas. Hyperbolas are defined as the set of all points in a plane, the difference of whose distances from two fixed points, the foci, is a constant. So these two fixed points, as you can remember from a previous video, is the foci. So let's point them out here. Let's say this is one of the foci, and its coordinate is c, 0. And let's say this is our other foci. It's somewhere towards which the curve bends, and so this coordinate is negative c, 0. The vertex is the extreme point here. Let's say that these are a and a prime, and we can write them as a, 0 and negative a, 0. Before going ahead and using the vertex, let's just go ahead and talk about the definition a bit more. So the definition, as it says, if we have, so these are like set of all points. The black curve here is just a set of all points. Let's say this is point P that has the coordinate x, y. Now, if we calculate this quantity, the distance between the points P and F, and subtract the distance from P to F prime, we will get a constant. So this is quite similar to the definition of an ellipse. There was a positive value there, but here it's a difference. Now this difference, as you can see, could be positive, for example, if PF is larger than PF prime, but it could also be negative if, for example, we looked at this point here. So due to the definition, we will get a constant, and that constant could also have a negative value. So that's why we have a plus or minus 2a. Now I will leave it to you to go ahead and solve and derive the equation of an hyperbola. It is very similar to that of the ellipse. You would have to find the distance, like the square root of x plus minus c plus the square root plus the y minus 0 squared, right? And so you would have to expand that, and you would have to go through a couple of algebraic, like a detailed algebraic manipulation. You'd have to square both sides and all. And finally, you would have to use this quantity. C squared is equal to a squared plus b squared. We did this similarly. In the ellipse, we had a negative sign that we divided by, right? So I will leave it up to you to go ahead and solve that. And that will give us this format. X squared over a squared minus y squared over b squared is equal to 1. This is the standard form of the equation of a hyperbola. Okay, so this is our standard form. Now this is if the center was at 0, 0. Otherwise, we would have this equation, x minus h squared over a squared minus y squared, or y minus k squared over b squared is equal to 1. This is also a standard form. It's just in terms of a shifted, like a translated hyperbola. So now let's go ahead and define the quantities that we would need to, like the parts of the hyperbola. The center of this hyperbola here, let's say C, is at the origin, the one I've drawn here. So this is the center, this is C here. And then we have the vertex, or the vertices, which are here A and A prime, right? So vertices A and A prime here is plus or minus A, 0. You can write them separately. You can write plus A, 0, minus A, 0. And then we have the foci, which are F and F prime here. these are at the points. So you could right away just write this c comma 0 plus minus c comma 0, or I'm going to use the eccentricity, if you remember that from the previous videos. In terms of eccentricity, we would have ae comma 0. Now, why is that true? In our case, in here, if you remember, the eccentricity of a hyperbola is greater than 1. So let's quickly review that. If you look here, you can see that if the eccentricity was very close to 0, it was like a circle. And if it was slightly higher, it's like an ellipse. So from 0 to 1, it's like an ellipse. But right at 1, we have a parabola. And the eccentricity is then, when it's greater than 1, you have the hyperbola. So this is for a hyperbola that's like oriented vertically like this, but we are looking at a different one. However, the eccentricity wouldn't be changed. So as you can see, if a was a here, the vertex is multiplied by a number greater than 1, then we would definitely have something like that, like the focus, right? So that's the foci. And so let's go ahead and write down the eccentricity. The definition is as before. We have E is equal to square root of 1 plus b squared over a squared. This is just different in the sign. This is 1 plus b squared over a squared, since it must be greater. And in ellipse, we studied that was 1 minus b squared over a squared. So now we will be defining the other quantities in terms of the eccentricity. If you look here, one of the important characteristics of this graph is the asymptotes. There is an asymptote here and an asymptote here for the hyperbola. These asymptotes have this form. See the gradient, right? So b over a. What is b here? The b is the length of the conjugate axis. So let me go ahead and show you what the conjugate axis is. If I draw a line up from the vertex, and kind of construct a box here. This distance on the top is a b. Okay, so maybe showing it here would be better. This is b, and this distance is an a. So the b represents the height, and this is the run, right? Rise over run. That gives us a negative gradient here because the run is negative. And here you would have just the opposite. You would have positive b over a. Y is equal to plus b over a x. So equation of asymptotes are y equals plus or minus b by a x. Now this is for this orientation. If it was flipped, we would have to switch the x and the y, right, for the asymptotes. Now, in order to define the asymptotes, we went forward and talked about a particular thing, the transverse axis and the conjugate axis. So the transverse axis is what connects the vertices. So length of transverse axis here is 2a, as you can see here, and this is represented by a prime. So if you know the value of a, you can just calculate this. Length of conjugate axis axis here is 2b. And this can be represented on the graph. I'll show these points. Let's say this is b prime, and let's say this point is v. So the length of v to b prime is the length of conjugate axis, which is just sorry, I have made an error here. It should be 2b. There are a few more interesting parts that you can talk about. For example, like before, the equation of the directrices. We have two of the directrices here. These are, so x is equal to plus or minus a over e. Now, why is that so? Let's have a look at this. And a is here, and e is greater than 1, right? So the directress is something like this. Let me use a different color to point that out. Maybe yellow. Okay, orange. Let's say the directrix is, it's always right before that graph, right? So it's something like that. Sorry, here. So that's one of the directrix. And here's another directrix. So these are the directrices, and we can kind of represent them here with geometrically by using d and d prime and d. So these are the equations. One is a negative a by e, and one is a positive a by e. So let me use d and d prime. Similarly, like before, you can define the lattice rectum as well. The length of the lattice rectum here is going to be 2b squared over a, and the length of the lattice rectum is also here going to be 2b squared over a. So length of lattice rectum, or you can in plural call them latera recta, is 2b squared over a. And if you want, you can also write down the equation of the latera recta by just using x is equal to negative c and x is equal to positive c. Or you could also think of the c as this term. X is equal to plus ae and x is equal to minus ae would give you the equation of the latera recta. One thing I forgot to mention here is the reason for this, this is, eccentricity is defined this way, c over a. And the c is larger than the a, and so that is why the eccentricity is greater than 1 here. Now, if our axis were shifted, we would have something like this: y squared over a squared minus x squared over b squared is equal to 1. And in this case, you would just have to shift the y's and the x's. And for coordinates such as the foci, you know that the foci would be on the y-axis instead of the x-axis. So you'd have to shift those. The vertices would be on the y instead of the x. And so you would have to also have the vertices like that. So what I mean is this: if this was my hyperbola, as per this equation, these are the vertices, and so we would have like 0 comma plus minus I think a here, plus minus a, and the foci would be this would be negative a, and this would be 0 comma positive a. The foci here again is 0 comma c and 0 comma negative c.